As a Mmath solution of 2019, I'm solving from 9. The previous ones are solved in the last videos. This is also a linear algebra question like question number 8. Suppose that A and B are two n into n matrices with real entries such that the sum of their ranks is strictly less than n. So that there exists a non-zero column vector. There exists a non-zero column vector x of Rn such that Ax equal to Bx equal to 0. Okay, so let's solve it. So consider a matrix C, A and B, a column 1. So the rank of C is the maximum number of linearly independent rows in C. Then rank C less than equal to rank A plus rank B less than n. So consequently, the column C are linearly independent. This is linearly dependent, and there exists a non-zero vector x belong to R to the power n such that Cx equal to Ax Bx equal to 0. So it means that Ax equal to Bx also equal to 0. Hence, for this structure, this is proved. Last question. This is about probability. Suppose that n persons are in a party. Every pair of persons meet each other with the probability of lies between 0 to 1, independent of the other pairs. If ni be the number of people the ith person meets in the party for all I belongs to n with I not equal to j in this thing. So we need to show that probability of n I equal to k and j equal to l n minus 2, this thing. Okay, so quite a long one. So we need to take an extra page for this. So here, introduction of the two events n of I equal to k in j l and I meets j. And another one where I does not meet. So this is k in j equal to l and I does not meet j. Assume that event A happens. The event A happens, then I meets j and I meets k minus 1 other persons. That is from n minus 2 possible persons. So obviously n minus 2. These are the choices of persons except j that I meets. So the probability that I meets k minus 1 persons, I meets k minus 1 except j is n minus 2 k minus 1 p to the power k minus 1 1 minus p whole to the power n minus k minus 1. So further, j meets l minus 1 persons except I, that is from n minus 2 possible persons. So n minus 2 c l minus 1 choices for the person, that is except I meets j. So the probability that j meets l minus 1 except I in this case will be n minus 2 c l minus 1 p to the power l minus 1 minus p n minus l minus 1. Only k is replacing l. Okay, so finally we can say probability of A is p n minus 2. I'm writing in this way, l minus 1, k minus 1. In order to save some space, k minus 1, 1 minus p, n minus k minus 1, n minus 2, l minus 1, p to the power l minus 1, and 1 minus p, n minus l minus 1. This is equal to n minus 2 c k minus 1 into n minus 2 c l minus 1 into p to the power k plus l minus 1. And this will be what? Minus p. So 2n minus k minus l minus 2. So assuming that even b happens, then I meets j and j meets k. J means k other number of persons, k other persons from the given possible n minus 2 options. So n minus 2 ck are the choices of persons except j meets I. So probably that I meets k except j is n minus 2 ck p to the power k 1 minus p n minus k minus 2. So further j meets L except I. So therefore n minus 2 c L choices we have persons. So the probability that j meets L except I is n minus 2 c L p to the power L 1 minus p to the power n minus L minus 2. So finally we can say that probability of B here 1 minus p, same pattern, n minus 2 c k p to the power k 1 minus p whole to the power n minus k minus 2 n minus 2 c L and p to the power L 1 minus p n minus L minus 2. So this is finally can be rewritten as n minus 2 c k n minus 2 c L p to the power k plus L a 1 minus p 2n minus k minus L minus 3. So we can deduce that probability. So the final value n of I equal to k, n of j equal to L is nothing but PA plus PB. So we can just put these two values and we get your answer. Okay, so we have already calculated PA and PB. So I'm just rewriting n minus 2 ck minus 1 n minus 2 c L minus 1 p to the power k plus L minus 1 1 minus p to the power 2n minus k minus L plus 2 plus n minus 2 c k n minus 2 c L p to the power k plus L 1 minus p 2n minus k minus L plus 3 minus 3. So that's the answer.